Suppose you are asked to write an algorithm to find the sum of these 7 numbers. Hopefully, it's not too hard for you. You add 3 and 1 to get 4, then 4 and 4 to get 8, 8 and 5 to get 13, and so on, adding one number at a time to get the final sum of 30. But I want you to add these numbers up in a different way. We're going to design a different algorithm, this time using induction, and then we'll implement the algorithm recursively. What I mean by this is that we're going to ask, what is the subproblem? What is the subproblem of adding all the numbers? The subproblem of adding all the numbers is adding all the numbers except the last one. So let's assume we know how to add up the first 6 numbers, and then we'll add the last one to that sum. But how do we get the sum of the first 6 numbers? Well, we assume we know how to add up the first 5, and then we'll add the last one of this subproblem to that sum. And we continue this way, solving smaller and smaller subproblems until we get to the trivial case, the base case. What's the base case? The base case is when we have no numbers to add anymore. Let's code this up in your Jupyter notebook. First, let's set up a little unit test. Write the base case. Call the function recursively to solve the subproblem. And add the last number in the list to the value returned by the call. So here you have a recursive function to add up the numbers in an array. It's certainly not the only way. Your solution might be different. Go ahead and play with it. Don't forget to test the empty base case and any other edge cases you can think of. Now let's trace this function as it runs. Every time sum is called, there's a new instance of the code running. The first instance gets the whole array with all 7 numbers. It calls sum on the first 6 numbers. Another instance of the function is created. It calls sum on the first 5 numbers. And so on down the call stack until the last instance of sum is created and it's asked to sum up the numbers in an empty array. So this last function returns 0. Then the previous instance adds 0 to the last number in the array, that's 3, and it returns 3 up to the calling function. This continues up the call stack till the second instance of the function returns 24, and the first function adds 6 to that and returns the final answer of 30.